All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. The James Webb Telescope is one of astrophysics' biggest breakthroughs and has never failed to proffer groundbreaking discoveries. Just recently, the James Webb Telescope made another groundbreaking discovery in our solar system. Not much has changed over the years. Such familiarity has made it easy to assume that everything that could make our solar system has already been discovered. There's nothing more to see. However, we couldn't be more wrong. In space, even though most of what we have found is ancient, the universe is still expanding, and more objects are born. The James Webb Telescope has captured some of these new objects. Michio Kaku, one of America's foremost theoretical physicists, also expressed shock over these new and unknown objects passing by in space. One has to wonder if the appearance of these objects brings good tidings. One thing is certain, though. This presents a new learning curve in the world of physical science. What are these 500 new objects found? What labels would these new celestial bodies fall under? Join us in this video as we unravel the 500 new objects the James Webb Telescope has just detected passing by in space. Just recently, NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA, teamed up to give astronomers the greatest gift they could ever get: the James Webb Space Telescope, JWST. This great gift is the chance for them to view the past at the earliest stages, and dare we say, the creation of the universe itself. Astronomers worldwide were taken to the very edge of time. The James Webb Telescope was dubbed the premier observatory of the next decade and one of the greatest scientific achievements of our time. The James Webb Telescope opened the doors of outer space wider and took us down the lane to where it all began. James Webb was launched into space on December 25th, 2021, to take pictures of the unknown and unravel the many mysteries of the hidden universe. The cutting-edge technology and enhanced infrared detection equipment that the telescope is outfitted with will enhance the unique perspective of the universe that the Hubble telescope has given humanity, and reveal the hidden intricacies of the universe. With its low Earth orbit, the Hubble telescope took several pictures of the furthest regions of the universe never seen before. The Hubble telescope also captured the historical periods of our universe, examining the history and evolutions of the many galaxies, stars, and nebulae. Hubble also described the characteristics of black holes, exoplanets, and the accelerated expansion of our universe. The Hubble telescope's groundbreaking achievements won the Nobel Physics Prize in 2011. The James Webb Telescope is the next phase in our collective adventure of discovering the universe's secrets and the search for extraterrestrial life. The Hubble telescope set the pace for deep space exploration, and the James Webb Telescope is expected to outdo the Hubble telescope's limitations. The Hubble telescope's images defined modern physics and opened our eyes to what lies beyond. The Hubble telescope's achievements also catalyzed our existential curiosity. It lit the fires in our hearts and increased our thirst for knowledge of the universe we belong to, and whose elements can be found within us. The James Webb Space Telescope scientists announced that as soon as they started taking data with the shiny new Deep Field Telescope, they realized there might be more distant galaxies than they were anticipating. So, the 411 is that the universe produces galaxies faster and earlier than many researchers thought. Barely a few 100 million years after the Big Bang, there were already a lot of galaxies. The James Webb Telescope has just given us access to view how it all began, with all the intrigues of a 3D movie. Further research has suggested that galaxies may have started to form barely 100 million years after the Big Bang, which occurred nearly 14 billion years ago. This timeline challenges the astronomers' theories about how and when the first galaxies were formed. One of the features that make the James Webb Telescope far superior to the Hubble telescope is its size. The size makes it stand out among the space probes. The James Webb has a 6.5-meter mirror of 18 gold-plated hexagonal parts. With this, the telescope can record light from objects 6 times faster than the 2.4-meter diameter lens of the Hubble telescope. However, James Webb's biggest advantage over the Hubble telescope is its high sensitivity to infrared light. The James Webb Telescope can see wavelengths between 0.6 to 28.5 micrometers from the mid to the red end of the infrared spectrum. The James Webb Telescope represents the newest generation of space telescopes. Its capabilities far surpass those of its predecessor. Since it can focus on the infrared portion of the electromagnetic spectrum, the James Webb Space Telescope has a unique advantage in studying celestial objects which emit longer wavelengths, thus enabling it to peer deeper into the mysteries of the universe. Unlike visible light, infrared radiation can penetrate cosmic dust clouds, which often block our view of the many distant galaxies in our universe. If we cannot see through the cosmic dust, we won't be able to get accurate data to study. By looking through these cosmic veils, the James Webb Telescope offers an unparalleled perspective on the early universe. This new perspective reveals the evolution and formation of galaxies, shedding light on the cosmic processes that shaped our present-day cosmos. The James Webb Telescope was placed on the second Lagrange point because it was the best position for the telescope to perform optimally. At the L2, it could explore whatever it wanted beyond its primary objectives. Now the James Webb Telescope also helps us keep an eye on our solar system, transmitting back to Earth news about whatever happens that is worthy of note in our solar system. One of the most interesting research areas James Webb captures within our solar system is the exploration of asteroids and comets. The James Webb Telescope diligently observes these celestial objects, providing valuable insight into their composition, structure, dynamics, and most importantly, their origin, evolution, and potential impact risks. These observations contribute significantly to our understanding of the formation of our solar system and smaller bodies within it. Shedding light on the processes that shape the planets and moons, our solar system works in complete balance that must stay in order, and every single particle must always be in a specific position. With a telescope like James Webb, we can learn about intricate movements, and if anything starts to shift out of order, the changes can be detected on time. In addition, the James Webb Telescope gazes into the outer planets of our solar system, particularly the gas giants that have fascinated us for the longest time. Jupiter, Saturn, as well as the ice giants Uranus and Neptune are important solar system members, but they are so far away we haven't been able to study them exhaustively. However, by studying the atmosphere, weather patterns, and cloud formations, the JWST offers a glimpse into the complex dynamics that govern these huge planets. It also provides unprecedented detail and resolution, allowing scientists to deepen their knowledge of planetary physics and atmospheric processes in ways that were unheard of even as recently as 5 years ago. In the quest to unravel the mysteries of the cosmos, the James Webb Space Telescope also investigates the mysterious forces of dark matter and dark energy. As odd as it might sound, these two elements, dark matter and dark energy, far outweigh ordinary matter and energy. They are even believed to contribute to the gravitational dynamics of galaxies and shape the universe's large-scale structure. The James Webb Telescope has gone a long way in scaling humans' understanding of the solar system by observing the gravitational lensing effects caused by dark matter and helping to map its distribution and understand its role in cosmic evolution. Similarly, dark energy, an elusive force driving the universe's accelerating expansion, has been a subject of great interest for quite a while now. In studying outer space, the James Webb Space Telescope aids in understanding dark energy by observing the most distant supernovae, which serve as cosmic distance markers. These observations enable scientists to measure the universe's expansion rate over cosmic time, providing crucial information further to refine our knowledge and understanding of the mysterious force. It doesn't end there. The JWST conducts extensive research and observations of nearby galaxies, providing detailed images and spectral data that enable researchers and scientists to study their structure, star formation rates, and evolution. The JWS's ability to capture infrared light allows it to pierce through cosmic dust and reveal the hidden regions within galaxies, thus unveiling the mechanisms driving their growth and the interaction between stars and gas clouds. Although it would seem like a bit of a stretch to investigate the nearby galaxies when there is still so much about our galaxy we have not yet known, every single detail we can learn about other galaxies can uncover truths we have not noticed about our galaxy. Everything in our universe works hand in hand, some more subtly than others. Hence, scientists are always on the lookout to catch some of the more subtle occurrences. Celestial events such as supernovae, gamma-ray bursts, and other fleeting yet powerful phenomena across the cosmos are usually ranked top on the list of the biggest cosmic events to watch out for. Supernova explosions that mark the end of a star's life are often the most observed cosmic events. The James Webb Space Telescope plays a crucial role in capturing the spectral signatures of supernovae, thus allowing scientists to analyze the emitted light across a broad range of wavelengths. Researchers study the characteristics of the light emitted by a dying star as it breathes its last in a beautiful explosion of poisonous gamma rays and shiny celestial light to gain more insight into the mechanisms underlying these cataclysmic events. Scientists can now investigate the literal nature of the progenitor star, the dynamics of the explosion, and the subsequent dispersal of elements that enrich the surrounding space. Just like the gamma-ray bursts pose intriguing questions about the most energetic process in the universe, the James Webb Space Telescope's swift response capabilities enable it to promptly observe these brief and intense bursts of high-energy gamma rays. The JWST can also capture the afterglow of a burst across the electromagnetic spectrum, including infrared light. It also provides critical data for understanding the nature and origins of the cosmic light shows. Scientists can probe the environments in which the gamma-ray bursts occur, such as massive stellar explosions or the collision of neutron stars, and gain a deeper understanding of the physics which drives these extraordinary events. Beyond these supernovae and gamma-ray bursts, the JWS also focuses on transient celestial events, which extend to a wide range of energetic phenomena happening across the universe. Some of these events include tidal disruption events. Tidal disruption events are situations where a star is torn apart by the heavy gravitational pull of a supermassive black hole or the collision of neutron stars. These tidal disruption events often give rise to gravitational waves and emissions across the electromagnetic spectrum. By quickly responding to these events and capturing their spectral signatures, the James Webb Space Telescope provides crucial data in unraveling the underlying physical processes at work. It also helps scientists understand the extreme environments, the energy release mechanisms, and the intricate interplay of matter and forces in these extraordinary events. These notable celestial events serve as windows to extreme cosmic environments and provide invaluable clues about the physical processes at play. Through its ability to rapidly observe and analyze transient celestial events, the James Webb Telescope plays a crucial role in deciphering the many mysteries of the universe. By capturing the spectral signatures of these celestial events, the telescope enables scientists to figure out the extreme environments that give rise to these events. One of the extreme events is the appearance of unknown objects in our solar system. While it is normal for our solar system to play host to some visitors like the Oumuamua, we have never witnessed the influx of this many stellar visitors. There has been no way to explain the sudden rise in our solar system's visitors, and the discovery of 500 new and unidentifiable objects in our solar system has left many scientists and astrophysicists nonplussed. These new stellar bodies pose an intriguing mystery to scientists. Despite many rigorous observations and analyses, these objects have remained unidentified and uncategorized. Despite this setback, they still represent a fascinating array of celestial entities, ranging from more familiar heavenly bodies such as asteroids and comets, to the more unfamiliar and potentially novel celestial entities that have made their way into our neck of the woods, or better still, our neck of the universe. The sheer diversity and quantity of these unidentified objects present an exceptional opportunity for scientific exploration and discovery, but at the same time could pose significant threats. While the discovery of 500 new objects in our solar system is exciting in itself, it raises questions as to their origins. One of the most intriguing theories concerning the origins of these stellar visitors is that they were ejected from black holes. Black holes are one of the cosmos's most interesting phenomena and, to a large extent, remain an enigma to us. Black holes are celestial entities formed from the collapse of massive stars. They possess such intense gravitational forces that they can disrupt nearby objects and fling them further into space. If these unknown objects were expelled into our solar system from a black hole, it would be a testament to the immense power that black holes wield. It would go on to prove that black holes can do more than swallow unfortunate bodies in their path. It also spits the material out like a space tornado. An intense tidal force exerted by black holes can tear apart stars or any planetary body, thus creating a tumultuous environment from which debris and fragments are violently ejected. But we wonder if indeed it can eject materials that it has trapped within itself. Voyager 1 also recently detected an intriguing anomaly in its path. There were many signals, most of them a little difficult to decode, but one of them said that the Voyager had succeeded in detecting the presence of about 300 unidentified objects passing by in the cosmic expanse. These mysterious entities were said to be emerging from the depths of interstellar space and incredibly confused scientists worldwide. These 300 objects, which remain unidentified, challenge our understanding of the cosmos, as they are the remnants of ancient celestial bodies and drifting relics from distant star systems. Voyager 1, being in the outer regions of our solar system, is subjected to extreme cold, with temperatures reaching as low as minus 202 degrees Fahrenheit. Such extreme temperature variations can impact the performance of electronic components, leading to unexpected behaviors or errors in data transmission. These, however, aren't the only issues. There is also the presence of micrometeoroids, tiny dust particles or fragments of comets and asteroids, which can also pose a threat to Voyager 1. Despite its small size, these micrometeoroids travel at high speeds and can cause damage upon impact. Even a tiny collision with a sensitive electronic component can disrupt its functionality or create an interference with the transmission of data. While scientists tried to decode the initial data transmission of these unidentified objects, Voyager 1 captured one of the most intriguing theories was that maybe we had finally come in contact with an alien civilization. Fortunately, although some may say otherwise, it happened to be the discovery of new celestial bodies in our solar system. However, one has to ask the question of whether or not these unidentified objects are more than relics from faraway star systems. What if these unidentified objects signify the existence of previously unknown phenomena and uncharted realities waiting to be unraveled? The James Webb Telescope was created to bring light to events that occurred billions of years ago, when the light emitted from these phenomena finally reaches us. By doing that, the JWST discovered enormous galaxies born closer to when the Big Bang occurred. The telescope has discovered enormous galaxies that are 600 million years or less younger than the occurrence of the Big Bang. Scientists are not sure what formation processes these early galaxies took, as they are too big to have been formed by the same processes other galaxies were formed with. We have seen galaxies that formed in short periods, and we have also seen small galaxies that are formed closer to the beginning. These discoveries have forever changed how we see the universe and what we accept as absolute truths. How do you feel about these new unidentified objects that have been found in our solar system?